Televised show will include 4 women and 3 men as panelists. And how many ways can the panelists be seated in a row of 7 chairs? So we're saying we have 7 chairs in a row. We're trying to figure out the number of different ways we could arrange these 7 panelists. So in the first chair, there could be 7 different choices. In the second chair, there are 6 different choices, and so on. Or you could look at this as, so this is, you can see that's 7 factorial. Or you could say I have 7 panelists, and I'm wanting to arrange all 7 of them, which, I said that these are the same thing before. So let's plug that into the calculator, 7 factorial. Or you could have done 7 NPR 7. It's the same number. This gives us 5,040. All right, and how many ways can the panelists be seated if the men and the women are to be alternated? So that means I have to go woman and woman and woman and woman and woman, right? 1, 2, 3, 4, 5. Wait, no, it's too many. 1, 2, 3, 4 women, 1, 2, 3 men, 7 total. Okay. So if I'm to do it this way, then this gets a little more complicated. I could say, well, in this first spot, I have 4 different choices. So if I was to take it from the counting, just using the multiplication principle, let's see how I would do this. For the first choice, I have 4 different women that could seat there. And, there's nothing saying I have to do these in order. But the second woman, well, there's only 3 different women that could go there, and 2 different women that could go there, and thus 1 woman that goes there. And for the men, well, there's 3 men, so I'm going to choose from 3 men that could go there, 2 there, and 1 there. You'll notice this is kind of interspersed, but really this is 4 factorial times 3 factorial, or 4 permute 4 times 3 permute 3. So 4 factorial times 3 factorial, which I'm just going to put into my calculator, 6, because it's easy. That's 144. There are some of these factorials that might be worth having memorized. 4 factorial is 24, 3 factorial is 6. All right, and how many ways can the panelists be seated if the men must be seated together and the women must be seated together? So let's see, let's think about how this could go. We could go all the women and then all the men. Or I suppose we could have done all the men and then all the women. And if you think about the number of ways that this can happen, it's actually the exact same question as what we just saw. There's going to be 144 ways if we do all the women and then all the men. There's also going to be 144 ways if we do all the men, then all the women. And there is no overlap between the 2 of these. If I'm talking about all the women and then all the men, I'm not going to be double counting if I just add these together. So, I'm thinking about my union rule here whenever we're talking about the total number of ways these things can happen. And so we end up with 288 ways in total, where if all the men are seated together and all the women are seated together, because they're kind of, like I said, lumped into these 2 groups. You'll notice I'm adding these numbers together instead of multiplying. I'm adding them because I'm saying this is kind of an alternate way that things can happen. The multiplication principle is when we're going down our tree, we're saying we have this many branches, we can go this many branches there and this many branches there and so on. We're branching off repeatedly. That's when we use the multiplication principle. When we add them together, we're saying, okay, this is when the women are first. And this down here would be the men first. It's kind of an alternate way branching to begin with. So if we're doing the number of women first, then there's 144 different ways to do that. If we're doing all the men first, there's 144 ways to do that. And so if we're counting up the total number of branches here, you can see I'm just adding those together. It can be a little bit tricky trying to determine if you're going to be multiplying or adding these things. But like I said, if you're going deeper in the tree, then you're multiplying. If you're looking at an entirely different branching, a different, like an alternate reality sort of situation, then you're going to be adding them. All right, and how many ways can 1 woman and 1 man from each panel be selected, or from the panel be selected? Well, in this case, we're just saying we're picking 1 of each. So from the 4 women, we're picking 1. And from the 4 men, or from 3 men rather, we're picking 1. In this case, we would multiply these because we're saying we're picking, well, maybe I'm overcomplicating this by saying these are permutations. It's just 4 times 3, really. But in this case, we would multiply these instead of adding them because we're saying, okay, for each of the different 4 ways I could pick a woman, there are then 3 different ways I could pick the man. And so we end up with a total of 12 different ways to pick 1 woman and 1 man from the panel.